Will I begin? Sir, shall I begin?
Happy Independence Day, sir.
I wish you the same. Chandrika ma'am or Arun sir, shall we begin the class? So good evening one and all. Dear
Good evening,
students
sir.
and teachers.
Good evening, sir.
Okay, at the very outset, wish you one and all a happy Independence Day.
Same to you,
So,
sir.
Thank you,
thank
sir.
you, thank you. So the Independence Day reminds us of one thing: freedom. And in this regard, I want to say freedom is not what is called as um, some gift like, rather freedom is an responsibility. I want to say what my professor had told us when we were studying our masters and so on. There is something called as some responsible freedom. Actually, there were a lot of rules when we were studying our masters and so on. Then suddenly the principal and the manager was changed that year. They were transferred and they were changed. A new manager, his name is Father Alex Katil. He was a person who addressed the entire batch of students, and he told, lot of rules are there, regulations are there. But this year, we are what is called as reducing the rules, or we are sidelining the rules and giving you the freedom. And he told one word especially: freedom which is responsible from your part. Means freedom is given with regard to attending of class, and a lot of things were there. A lot of restrictions were there earlier, but those restrictions were slide down, and he told freedom is given. Now it's up to you to how to use your freedom, whether to use it properly or whether to misuse it. And he told that using and misusing depends upon how you take up your responsibility of your freedom. So I'm telling, as we celebrate our nation's Independence Day, the freedom, the enjoyment that we have, it's only I want to stress today, freedom is a responsibility. And we have to responsibly use our freedom. So with this thought of the day, let us begin the class. And I'm happy also on this Independence Day, you're also beginning a new chapter. So remember
Jai
carefully.
Hind, Jai Bharat.
Bharat?
Jai Hind, Jai Bharat.
Okay, Jai Hind, Jai Bharat. So with this thought, we'll begin with a happy note. We'll begin the new chapter. So always remember, freedom is a responsibility. Okay, a lot of things are going on in the world, and you, present generation, you are the future of our nation. Remember, freedom is a responsibility. Not that I given freedom, I can do anything I want. No. So freedom is a responsibility to live up to the mark. So I don't want to specify what the mark is. Each one, we are grown up, we know what the mark is, what the statutes are. So these days we are hearing a lot of news. Just a day back, or things are so many things we are hearing, so many things are happening. So it's the right time to think how responsibly we are using our freedom. We are getting freedom in a lot of area, a lot of space, and so on. At home, we are getting freedom. At institutions, we are getting freedom. In society, we are getting freedom. But how responsibly am I using this freedom? Am I using this freedom responsibly, or am I misusing the freedom? So it's my humble request before you go to bed just to analyze this question and to answer yourself. Am I using my freedom responsibly, or am I misusing my freedom? Freedom, not only in particular sense, we are getting freedom in a lot of areas. As I told, at home, at institutions, society, in lot many spaces we are getting freedom. So just think this one. With this thought, we'll go ahead. So we'll go to the another chapter on this new beautiful day. Okay, most of the students, boys, now even girls also started playing cricket. I've played cricket. Yes or no?
Yeah, sir.
Okay. So usually when you play cricket in your local areas, sometimes you may have a ground, sometimes you don't have a ground. I still remember the first stages of me playing cricket was on the roadside. We used to play in roadside. We used to play in the coconut field. We used to
Gully
play in the
cricket.
coconut. Then we also remember playing near the just up behind the railway station. There was some place we were playing there. So sometimes when we play cricket, we may have a proper ground, a ground setup, or we make sure whatever space we get, that the space into a small area for playing cricket. Yes or no? Isn't it? Those who are playing cricket, boys and girls,
Yeah, sir.
your childhood memories. Us. So here, what happens when we create a field for ourselves? Let us say near a street or a coconut field, and so on. There is no particular pitch alike. We don't worry whether pitch is straight, whether the pitch is this one, and so on. Somehow we take something, level it, and we play it. Yes or no? As
Yes, sir.
you have to play the cricket. You have to enjoy the game. Now coming to the same game in a matches like let us say IPL or an international cricket or some Ranji trophies and so on. There is a stadium, and the stadium has got a ground. So in that place, the place was less. There wasn't no proper pitch and so on. But when it comes to stadium, the ground is little vast, and the ground has got pitch. Yes or no? The ground has got
Yes,
pitch,
sir.
Yes, sir.
and we know that in one stadium in a ground, at least there will be some 10 to 12 pitches. Hmm? Let us say if this is my stadium, there will be a lot of pitches. Hmm? Those who have watched IPL, you would have seen. If they are batting, there will be another pitch beside that one. I think recently, not IPL. Is it IPL? I don't know. World Cup match. I don't know. Is it IPL or World Cup match?
ODIs.
Exactly. No, no. I think IPL only. In particular, ground in Eden's Garden. No,
It's only in
I'm not
America.
sure. Not America. Not World Cup. I think IPL only. There was one match uh, against. It was the last one, last stage of league matches only. Against one team, there was one match in the ground. I think it's either Ahmedabad ground or Kolkata ground. I don't know exactly. The match was played on one particular pitch where they had never played any cricket match at all. That was the first time in that pitch they played a cricket match. I don't know which was it in Ahmedabad or was it in Eden's Garden? Still, I'm doubting. Huh? But the impact was it was a slow pitch. I think Eden's Garden only. I think they played in the pitch number 8 or something. First time they played. Pitch number 8 or pitch number 10, they don't know exactly. First time they played a cricket match there in Eden's Garden. Actually, Eden's Garden is like a pitch where you can have high scoring match and so on. But that game, they had a not so good innings. No? Then the commentators analyzed the pitch and they told it's a slow pitch, and for the first time they're playing the cricket there. Hmm. So only when we consider in this stadium where the ground is got, it has got lot of pitches, some 8, 10, 11 pitches, and basing upon which pitch I take, basing upon the pitch I take, they decide the boundary. Yes or no? So since we have got lot of pitches, okay, basing on the which pitch I take, if I take this pitch, according to this pitch, my boundary gets the boundary of my stadium or the boundary of my this one gets changed. So depending upon the pitch, my boundary is getting changed. So usually, this is what happens in most of the matches what we see in cricket. A stadium which has got a lot of pitches, they see, okay, they prepare. Okay, this pitch will get ready for the match. So they prepare that pitch from 2-3 days, and basing on that pitch, they set the boundary. So this is with regard to cricket. A very common thing that we all know. Now coming to mathematics, can you have like this? Can you have like this in mathematics? Students, if you're keeping quiet, I'm wondering whether I'm speaking alone or not. At least some sound
Yeah.
will make me. Okay, very good. Okay. Because online class now, since you are sharing the same mobile for meeting and screen, sometimes I get this doubt. As I am speaking alone, our students are there, so and so on. So can we apply the same concept in mathematics? The
Yes,
same concept of cricket and stadium. Okay. How we can apply that
Yes, sir.
concept? Okay, you're telling yes, sir. How we can apply the same concept of cricket, the number of pitches and setting the boundary in mathematics? Imagine the two instances I gave. One instance is playing cricket at home. Playing at home. Another instance I gave was playing at a stadium. And two stages also I gave. What are the things? Here you may not have a proper ground, not even a proper space or a pitch. Here you have got a lot of pitches, and basing that and there is one. So basing on this analysis, can we apply the same concept in mathematics? You told us how.
Some people pitches are same.
Max, what pitch we are using? Match, only we use pitch in match. We use pitch in match. But we don't use pitch in mathematics. In max, we don't use pitch. But we use something else.
Why, sir?
In max, what pitch you are using, man? Do you use pitch in max?
No, sir.
Then if you think little, you understand. In max, we use something. Instead of pitch, we use something.
Degree.
Degree? Come on. How can you vary a degree?
Angle, sir.
Both same. Why is telling degree? The unit of measurement is telling that you are telling the quantity.
Sir, graph.
Graph. Okay, you are getting the tail. I want the head. You have caught the tail. I want the head. Catch the head. The girl who told graph, just go a little deeper. You have caught the tail.
Axis, sir.
Axis. More, if you want to say more properly. Okay, axis.
Sir,
We'll take it.
slope.
Huh?
Slope.
Slope. No. Slope. We are going very deep. Axis. Okay. 75 or 80% correct. Putting all together will come something. We discussed all these things.
Sir, origin.
Origin, okay. Getting individual things.
So Cartesian plane.
Very good. Is it Gayatri or Bhavana?
Sir, Bhavana, sir.
Bhavana. Very good, Bhavana.
Thank you,
So,
sir.
same thing can be applied in mathematics with regard to Cartesian plane. So, if my ground is small, I got only one plane, XY plane, with one origin. Yes or no?
Yes, sir.
And this
Yes,
plane
sir.
is called as Cartesian plane. Cartesian coordinate system. Last time I explained you how the name Cartesian came. Rene Descartes. The combination of how the combination of coordinate geometry came and so on. So now if I take a plane, I told since I got only a limited amount of plane, I'm getting XY plane. Now let me take a plane which has got infinite length and infinite breadth. Length is very infinite, breadth is very infinite. In any direction, the plane is infinite. Distance cannot be measured, very infinite. let us say infinite means infinite. Just I'm marking it like this: infinite length and breadth. Then I can take any two mutual perpendicular lines. So here I can take any two mutual perpendicular lines. Yes or no? So how many lines have taken here? So I have taken any two mutual perpendicular lines, and the intersection of those two lines will give me origin.
Yes, sir.
So what I'm mapping? In this case, I'm getting how many Cartesian coordinate system? I'm getting different Cartesian coordinate system. Yes or no?
Yes, sir.
Yes,
So
sir.
now since my plane is very infinite, I can consider any two perpendicular lines, and those perpendicular lines are intersecting, and the point of intersection I call it as origin. So how, when I say a Cartesian coordinate system, is when I got a fixed origin. With the help of fixed origin, I'm getting two axes. See here, I'm getting two axes here. I'm getting two axes here. I'm getting two axes as fixed origin. I'm getting two axes here. Two axes here. So here what happening? Because of the infinite space in a plane, I can choose any two mutual perpendicular lines in any part of my plane. As a result, what happening? Because of this origin, I'm getting different Cartesian coordinate plane systems in this plane. 1, 2, 3, 4, 5, 6, 7. This can go on. It's almost like my stadium only. A stadium has got a lot of number of pitches, and how do I decide the boundary depending upon the pitch? Here, how I am defining this as a Cartesian coordinate system depending upon my origin. Yes or no?
Yes,
Simply
sir.
two perpendicular lines will not become a Cartesian coordinate system until and unless they meet at one point, and that meeting point is called as an origin. Remember the basic 2D class we took? We can't simply call two perpendicular lines as a, what is this called as an axis or coordinate system until and unless those two perpendicular lines meet at a point, a fixed point. So to define something as a Cartesian coordinate system or Cartesian plane, we need a fixed point. Depending upon this origin only, we say it. So what happens? Since depending upon this origin, okay, I say, okay, this coordinate system is so much away from the plane. So if I want to locate this Cartesian coordinate system, I will find out where is my origin is. The origin of this one is maybe some 3, 5. The origin of this one is maybe some 9, 15. So depending upon the position of my origin in the plane, I say, okay, this coordinate system is there. This coordinate system is the left, right corner. So when my plane has got infinite distance of space, I'm getting lot of amount of Cartesian planes, and those Cartesian planes are specified in the location depending upon their position of the origin. Do you understand? Same thing like what we do in cricket. So I set my boundary depending upon the pitch. Same thing, I define the location of my plane depending upon the position of the origin. Do you understand this concept?
Yes, sir.
Yes,
Boys,
sir.
do you understand this concept? Okay, very good. Now, now, now since the plane has got infinite distance, we came to know that we can have lot number of Cartesian planes. For time being, I'll take two planes. Let us take, this is my plane here. I'll take one axis here. I'll take one more axis somewhere here. Is it visible? Let me increase the thickness. Okay. This one I will draw it again for you since it is not visible. So now since my since my plane is an infinite space, instead of taking number of Cartesian systems here, I'll take two Cartesian coordinate systems. One Cartesian coordinate system I'll take it here. Another Cartesian coordinate system I'll take it here. Let us say. Let this be x, y, 0. Let this be x1, 0,
Y1.
y1, and 0, 1, o1. So I'm taken two Cartesian coordinate system. If I consider a point here, let us say a point here. See, this point is both in this plane also, this point is there. In this plane also, this point is there. Yes or no?
Yes, sir. Yes, sir.
Yes,
Listen
sir.
carefully. Listen carefully. The point is there in this position also, in this position also. But with regard to this Cartesian coordinate system, the value of this point is different. With regard to this Cartesian coordinate system, the value of this point is different. So if I take this coordinate system 1, 2, 3, 4, 1, 2, 3, 4. So this will be, if I take from this coordinate system, that point will be point 3, 4. Yes or no? Look carefully here. 3, 4. If I take from this coordinate system, the point is 1.5, 1. Yes or no?
Yes, sir.
So if I take from this coordinate system, the point is 3, 4. If I take from this coordinate system, the point is 1.555, 102, something. But the position of the point is same. The original position of the point is same, but because of the bringing of the new coordinate system, the value of the point is changing. That's all. In the new coordinate system, the position of the point is not changing. If you look carefully, since I introduced this new coordinate system here, the point has not moved. The point is there only, but the value is getting changed. Similarly, in the stadium, also cricket stadium, if you take pitch number 8, means the entire ground is not moving. The pitch is there, the ground is there, but we are moving only the boundary. The value of that boundaries are changed. Depending upon that boundary, we shift the, depending upon that pitch, we shift the, okay, that is 85 centimeter, this one is 85 meter this side, 70 meter this side, and so on. We shift to the leg side, off side, and so on. And we fix that boundary line. Similarly, the point is not moving here, the point is there only, but we are fixing another system there. Because of fixing that system, what happens? The value of my point changes, the boundary line changes. So, but I can get value for this point in this system also, in this system also. Yes or no? Though the
Yes,
value
sir.
is changing, I'm getting a
Yes,
value in this
sir.
system also, in this system also. So I can do it graphically, but I can also do it generally also. So what I can do, I can bring in a relationship of this point with this and this. I can build a relationship. Yes or no? I can build a relationship
Relationship.
between the first coordinate system and the
Sec-
new coordinate system. I can say old coordinate system and new coordinate system. Yes or no?
Yes, sir.
Yes,
So
sir.
this building a new
Yes.
relationship between the old coordinate system and the new coordinate system is called as nothing but coordinate transformation. This building a new relationship between the old coordinate system and new coordinate system is not called as nothing but coordinate transformation. So when we try to analyze a point from one system to another system, maybe from old system to new system, don't think means old means to make sure to make you understand from the original system to the new system. From to say another simple name is from one system to the another system. We can bring in a relation, and that type of building a relation is called as a coordinate transformation. Now we can understand. Now you understood what topic we are dealing. We are dealing with something called as
Transformation coordinate.
Formation of
we are dealing with something called as transformation of axis. So the topic we'll be dealing from today onwards is the topic of transformation of axis. What is this transformation of axis? I'll tell you. That means we just now we came to know we can build a relationship of a point from one coordinate system to another coordinate system. That relationship building relationship is called as a coordinate transformation. So how do we do this coordinate transformation? By transforming the axis. Yes or no? I'll transforming the point from the old axis to new axis. Did you understand? How I build a relationship? How I build a
Yes,
relationship from how I build a relationship of this point? I'll build a relationship of this point from transforming this point from the old to new. Means from this axis to this axis. See, the point from this axis, it becomes now this. If I change the color, you understand. So the original point is from this axis will be so much. If I transform to new axis, the point will become like this. See here. That means what I am doing, I'm transforming the axis of this point. So I'm building a relationship. I'm making a coordinate transformation by transforming the axis. Transforming the axis of the given point. Do you understand?
yes, sir.
Yes.
So we know that if I consider two coordinate system, the position of the point will not change, but the value of the point will change. Just now I gave an example. Remember the example of 3, 4 and 1.5, 1 or something. Yes or no? That example you understood. Did you understand that example?
Yes, sir.
So that means what happening? The position of the point is not changing, but the value of the point is changing. As a result, what I can do, I can get the value of this point by bringing the relationship between this axis and this axis. Generally, every time we know we don't have time to take a scale and a graph and draw and find it out. If the equation is small, no problem. We can plot out and can find it out. Imagine the equation is big. So what we do, we find a generalized relationship using some formula or something. So that relationship can be brought by what is called as by comparing the point from one what is called by comparing this point from one coordinate system to another coordinate system. So I can build in a relationship of this point from one coordinate system to another coordinate system. This building relationship is called as a coordinate transformation. How am I getting this coordinate transformation? How am I building a relationship between this system and this system? By transforming the axis of this point. If I take my original distance, for the old coordinate system, the point has got this much length in x-axis and this much length in y-axis. Whereas the point has got only so much of distance of x-axis in the new coordinate system and so much of distance in y-axis in the new coordinate system. So what is happening? Since I change the axis of my point to the old axis and the new axis, as a result, what happening? there is some change. Basing on the change, I'm finding the relation of the point with the other axes, and that is called as coordinate transformation. Since I'm doing it with the help of changing the axis, the process is called as transformation of axis. Do you understand?
Yes, sir.
Yes, sir.
So now you all understood what is transformation of axis. So transformation of axis is we are changing the axis of a point of a coordinate in order to build a relationship of that coordinate with the old and new coordinate. The entire process is called as transformation of axis, and the uh, relationship that we are finding is called as coordinate transformation. So much is clear.
Yes, sir.
Now, transformation of axis. Transformation of axis can be done in two ways. Transformation of axes can be done in two ways. Mainly, one is translation of axis. One is translation of axis. Another one is rotation of axis. That means I can translate an axis as I can rotate an axis. By doing these two different types, I can do the transformation of axis. Don't worry, we'll study in deep and we'll study theorems on this also. So now you understood what is a coordinate transformation, what is the transformation of axis, how we can do transformation of axis. Before going into detail, some basic things you should know with regard to transformation of axis. When we do coordinate transfer, when coordinate transfer is happening, how do we discuss this point? When coordinate transfer is happening, there is no change in the position of coordinate. There is no change in the position. There is no change in the position of the coordinate. Rather, there is change only in the value of the coordinate. There is change only in the value. Unless the coordinate of point is only getting changed. When we do coordinate transfer, you remember in one axis we are getting the point as 3, 5 or 3, 4. Another one we are getting 1.5, 2. That doesn't mean that I'm changing the point here. The value of the coordinate is getting changed, but the original position of the point is same. It is not getting changed. Please write somewhere this point very clearly.
Can you repeat?
When we do coordinate transfer, come back to this example. This example. There itself I told you last time itself when I was explaining this point. Come back to this example. This point. Let me take that point in some other color. This point P, let me take it as alpha comma beta. This point P alpha comma beta, the position of that point is not changing. Excuse me. The position of the point P is same. The original position is same. When I introduce the new, what is called as, let us say, when I introduce the new axis, the position did not change. The position is also same. But by introducing the new coordinate system there, only the value of this coordinate is changing. In this coordinate system, the value is different. Let us say 3, 5. In this coordinate system, the value may be some 2, 4 or else 2, 1, something. That means what? The point's position remains the same. The original position remains the same. Only the value, the coordinate value will get changed. The coordinates only getting changed. When we do coordinate transfer, this is called as coordinate transformation. Yes or no? We are building a relationship between one axis and another axis. In this axis, we are getting this point. In this axis, we are getting this point. Means we are doing a relationship of this point with two axes. This is called as coordinate transformation.
Yes, sir.
So when you are doing coordinate transformation, the original position of the point will never ever changes. The original position of the point will remain as it intact. It will never change. The only component that changes is the coordinate value. See your example. The point P is remaining there only as a fixed point. It is remaining there, but the fixed point distance is here different. So I'm getting my x and y value different here. My fixed points thing is different here. See here, it is from here to here so much distance, from here to here so much distance. So here I'm getting different value here. So because of the introduction of the new coordinate system, the position is not changing, rather the value of the coordinate is changing. So please keep this note somewhere. Understand this note very carefully. In transformation of axes or coordinate transformation, the position of the point will never changes, rather the value of the point changes. With regard to coordinate transformation, listen carefully. Is this point clear?
Yes, sir.
Okay, now we'll go to the next point. When we do coordinate transformation, same thing. We'll take this example again. When we do coordinate transformation, the point, let us say P alpha comma beta. This P alpha comma beta has got two different values here. One value is of this one, another value will be from this one. Another value, one will be of green, one will be of red. So when we do coordinate transformation, if I draw some length, some line segment, the length of line segment, the length of the curve, the length of the curve, the angle measurements, the area that can be drawn from this one, the area that I can form using this curve, these things will not change. For example, now see here, now I am drawing some line segment here. The length of the line segment will not change. If it is 3 centimeter here means it will be remaining 3 centimeter only. Unless if I take this line length of line segment, okay. If I take this, let us say, the length in this means, so in this plane, both the planes are included. If I take in this plane, so it doesn't mean that the length of this line is 3 centimeter in this plane, and in this plane is not 5 centimeter. No, the length is same everywhere. Correct? No.
Yes, sir.
So here the coordinates may be, let us say here the coordinates may be 1, 1. The coordinates may be some 5, 4. Here the coordinate may be some 4, 4. Here the coordinate may be some 8, let us say 9, 7. If you do take the distance formula, both the side, the distance is same only. The length is same. If you take the line in this axis, in this coordinate system, or in this coordinate system. So whether there is a coordinate transformation or anything, the length of the line segment will remain the same. Same thing with regard to curve also. If I take a parabola here, the length of this parabola curve is same for this one also, this one also, irrespective of coordinate system. If I measure the angle of intersection of these two curves, it is same for this. Let us say if the angle is some 30 degree, the angle is also 30 degree for another curve. If in this axis also. So
when I take coordinate transformation, the length of the line segment, length of the curve, angle of measurement, area of the curve, all these things will remain same. Why all these things are remaining same? Because of one particular property, the position of the point will never change. The position of the point is a fixed position. We know that a fixed position has got a constant length, constant area, constant angle measurement. Yes or no?
Yes,
We
sir.
saw a
Sir.
lot of problems in the locus. Huh? When we consider two fixed points, means the distance is same, the angle is same, the area bounded by that two fixed point is same. Whereas only a variable point, the distance is varying. Since my point is a fixed point, the position is not changing. That means my point is fixed. As a result of my fixed point, what happens? The length of line segment is not changing. The length of my curve is not changing. The angle measurement is not changing. The area of the curve bounded by this region is not changing. So when I do coordinate transformation, the coordinate values changes, whereas the position will not change, the length of line segment will not change, the length of curve will not change, the angle measurement will not change, the area of curve will not change. Do you understand so much?
Yes, sir.
Okay.
Yes.
Now my question is for you. Okay. First I will come to cricket. Then from that question will come to mathematics question. Now I told a stadium has got let us say some 8-10 pitches. We select one particular pitch. And basing on that pitch, we do what is called as we change the boundary lines and so on. Why we need to do so much of work? You have to do measuring, you have to fix that boundary line and so on. Huh? Why so much of extra work to be done? Can't we maintain only one single pitch? Since they got more workers, they got nothing to do. They do like this gymnastics or what? Why can't they maintain only one single pitch and maintain the entire thing? Why every time they have to take one new pitch and basing that new pitch they have to change the boundary line? Why? Especially for boys. Girls may find it difficult to answer this question. Since boys you play cricket every day, you can easily answer this question. Why? They can simply maintain one pitch and keep the same boundary line for all the match. Why they should keep some 8, 10, 12 pitches in a stadium, and for each match they take a new pitch and make ready that pitch from 3-4 days, and then they have to change. They not only make one pitch ready for one match, you know it, no? They get ready to alternate another two pitches if something happens. So basing on that alternative pitches, they should be ready with the sample boundary line behind. So why so much of gymnastics they have to do? Why so much of work and so much of time has to be wasted? They can simply have only one boundary and one pitch, a fixed measurements. Why? Any answer?
Because it should be equal, sir, for every pitch.
Okay, that is okay. I understood. So only I'm telling it should be equal. The pitch boundary line has to be equal and so on. Why they have to keep on? Why can't they keep only one pitch and maintain that pitch properly? Huh? Why can't they keep one pitch and maintain that pitch properly? Why can't they keep the pitch and maintain the pitch? What is it called as? Why can't they keep the pitch and maintain that pitch only one pitch? Excuse me. Hmm? No idea.
No, sir.
Okay. Boys, any idea? Why can't they keep only one pitch and maintain the pitch instead of having a lot of many pitches?
So if the pitch is not good, they don't get speed and movement
Very good.
effectively.
See, if you keep on playing on one pitch, the pitch gets changes. Yes or no?
Yeah, sir.
So what we do, we keep, we give some rest for that pitch and we go for another pitch. Same thing. You take your bike. Hmm. Most of us have got bikes and other motor vehicles in our homes. You keep on riding the bike. The bike, okay, it keeps running, etc. But at certain time, the what is called as the productivity of bike is maybe less. So sometimes the mileage may not much as we get earlier. It may not be as smooth as we are driving earlier. So at one point, what we'll do, okay, we take the bike to the showroom or something, and we give it for service. Yes or no?
Yes, sir.
The
Yes, sir.
same thing here also with regard to cricket pitches also. We don't give the cricket pitch for servicing. Rather, we keep that pitch as it is for a few days, few matches. So meantime, the pitch recovers. So once you keep on playing the same pitch, the pitch changes. So what they do, okay, if they play some 2 or 3 matches in this pitch, then they go for the other pitch and so on. So they take rotation of the pitches so that the pitch condition may not go well. If you take this World Cup matches, all the matches were conducted in which place? You know it. The matches were conducted in hello. All the matches were conducted in the places
US.
where US and Netherlands and so on. The places where the cricket was not played much, means the pitch was not maintained much. As a result, all the pitches were slow pitches.
Yes, sir.
And second innings, much more worst.
Yes, sir.
As the game went on, the second innings much more worse. The pitch became much more slow, and most of the matches were all slow targeted match.
Yes, sir.
Yes, sir.
You are wondering what is this? Is it T20 match or Test match? Yes or no? Because the pitch was like that. Since the
Yes,
pitches
sir.
were not maintained properly there, because that is a country where cricket is being introduced newly. Because those are the pitches of some football and so on. So they maintain maybe some 1 month or some 3 months back. They have maintained that pitches for cricket and so on. So those were the pitch not meant for cricket pitches. And in fact, one commentator, I don't know exactly his name, I forgot. He told exactly. BCCI and the cricket in the ICC, was the International Cricket Association, is making the risk of the players outfit health, because that pitches are not meant to play cricket there. Any injury can happen to any player. Of course, the comment that the commentator made was excellent comment. Of course, they wanted to promote cricket.
हेलो
and,
भाई
as
नवनीत
cricket-
कुमार, आपके पास कुछ नोट्स है क्या?
Hello, excuse me, unmute the mic.
ओके सर, ओके.
As a result, what happened? They wanted to promote a cricket, and as a result, they wanted to bring cricket to Olympics. Maybe within next Olympics or the other Olympics, they plan to bring cricket to the Olympics. Okay, that's the reason why I told they maintain
not one pitches, several pitches, to avoid like this problem of what happened in the World Cup pitches. So only in India, not only India, in any most well established cricket countries like England, Australia, and so on, the pitches are like that. Yes, they maintain more than 8 to 10 pitches in a stadium and so on. Now coming this concept. Now I asked why so many pitches are maintained, why so much of extra work to be done, because this is the reason. Now coming back the same question, why we need more than one coordinate systems? Why can't we simply enjoy with one coordinate system? Huh? I know actually when I was taking this concept in the offline class for the students, one student openly told, sir, already we are suffering with one coordinate system X and Y. Why you want to bring another coordinate system and eat our head? Of course, it was a little comical way of putting it together. Same thing. Sometimes it may run our mind with only one coordinate system X and Y. So much of headache, locus, this, that, and so on. Why you have to bring in another one coordinate system X10, Y1? Why? So this has a homework for you. Think on the basic of the what is this called as what I just now told. Why we need extra pitches in cricket? I gave the answer also for you. Why we need extra pitches in the cricket stadium for the maintenance of the pitches and so on. We discussed a lot of things. So similarly, why we can't satisfy with only one coordinate system in the plane? Why we need another one Cartesian system in a plane? Is it all necessary?
Sir.
Is it all necessary? Just a minute. I'll finish off. Just a minute. Is it all necessary? If it is necessary, why? If it is not necessary, why? So this is a homework for you. Please think. And my humble request, please don't refer Google and so on. Google will give you.
Okay, sir.
Okay,
If
sir.
you refer Google, I'll come to know. By listening to your answer, I'll come to know, because Google will give you standard answers. It will give you mathematical proper what is called as a proper
Sir,
reason.
Google
Basically,
will
multiplication
direct the answer, sir. It will not give the our solution by methods. It will give direct answer, direct solution.
No, if you have one system of coordinate plane, means it is easy to get answers
Sir,
and so on.
sir, and one thing, we don't use Google most.
Last,
We can
my dear student, last class itself, I caught red-handedly 2 students who used Google and answered me.
we can use only our brain. That again, our
No,
Google
that's
will
what
not
I'm,
answer only.
I'm trusting you and telling, okay, you're using your brain. Since it's
Okay.
since it's an
Okay, sir.
online,
Thank you, sir. Thank you, sir.
since it's an
It's my
online mode
pleasure.
of class, we don't know what things can go on. But
Okay, sir.
I am reminding you again and again, not
No, sir.
to refer
We will
Google.
use our brain and we will confirm that answer. We will say tomorrow evening.
So, okay, I'll be waiting for the personal answers. Please don't give me Google answers. So,
So okay,
as
sir.
told,
Always, sir. Always.
as you told, the trust is there, but it's my duty to what is called as remind you not
It's
to go
it's
and help.
it's it's sir.
So
It's correct.
what happens is you will try. Once you don't get answer, the mobile will call you. Come on, I am there. Use me. Come on, I am there. Use me. Because sir is going to answer the question. You have to
So,
answer the
sir,
question.
we don't break your trust, sir.
Okay. Just I'm telling. So I trust you, students. I trust
Hello,
you,
sir.
but I'm reminding again and again. Please don't go for help. Even if your answer is wrong, no problem. Because I am telling again and
Sir,
again.
please,
clearly,
one
okay.
condition, please. One condition.
Yes.
सर आप मैं हिंदी में बात कर सकता हूँ क्या?
Okay. I can understand. Let me see. If I don't understand, I'll ask some translation. Yes.
सर हमको ये होना कि जो हम सबसे चैट करते हैं क्योंकि हम वर्क शेयर करना चाहते हैं.
That chatting can be done in your personal thing, not in the classroom. Okay, understood. You share the work, you discuss. Very good. Because when we prepared for our exams and so on, sometimes we used to share topics and we used to discuss.
No, sir, you
Discussion-
should on the group chat.
So that, okay, that group chat you can do it, no issues, no problem. But not in the classroom. Because classroom, when you discuss or when you say something, it's disturbance for everybody.
Okay, sir. Okay, thank you. It's my pleasure.
Okay, yeah, it's good, it's good. So
Okay, sir.
we'll stop the
Thank you.
class here. So tomorrow I have given you a question to what is called think and come. The question is why we need to have multiple coordinate system. Plus, why we need to have more than one coordinate system.
So 1 minute, we will write the question in our notes.
Why we need to have
Okay.
multiple coordinate system.
Sir,
Okay, sir.
repeat the
Once
question,
repeat-
sir, please. Repeat the question.
Why we need to have a multiple coordinate system? Can't we
Okay, sir.
satisfy
Thank
with
you, sir.
one coordinate system? Okay. So kindly try to get the answer for this one with lot of discussions. We had a lot of discussions today with regard to cricket and so on. Keep that base and try to answer. We'll get a correct answer. So we'll meet tomorrow at this time. So once again,
Okay,
wish
sir.
you
Can we leave the class?
Okay, sir. Okay, sir.
Thank you,
thank
sir.
you, thank you.
Okay, okay. Can we leave the class?
Okay.
Okay, sir.
It's